Hi there, in this video I'm going to go through a past exam question on hyperbolic functions. So let's take a look at this question. So question number 4, given that y equals r hyperbolic sine root x, where x is greater than 0, in part A, find dy over dx, giving your answer as a simplified fraction. So let's have a look at how this is done. Let's go back to the paper and pen. So we have y equals r hyperbolic sine root x. R is, in other words, the inverse, so we have y equals, in other words, the inverse hyperbolic sine of root x. So let's rewrite that as, and you don't have to, but it's the inverse hyperbolic sine of root x, so that's what the AR means. Now we need to work out dy over dx, so we need to differentiate. So before I differentiate, let me rewrite this as, so I can rewrite this as hyperbolic sine y is equal to root x. And then I can differentiate both sides. So to work out dy over dx, let's differentiate both sides. So by differentiating both sides, so by differentiating both sides with respect to x, so by that we need to differentiate, so calculate d by dx of the left hand term, which is hyperbolic sine y, and we also need to differentiate the right hand term with respect to x, so d by dx of root x on the right hand side. So that is what I mean by differentiating both sides with respect to x. Now, to differentiate the right hand term, that is straightforward. It's basic differentiation. So to differentiate root x, or x to the power of half, we multiply by the power and subtract 1 from the power. However, let's concentrate on the left hand term. Let's call that star. And let's differentiate hyperbolic sine y as a side calculation. So as a side calculation, let's work out d by dx of hyperbolic sine y. Now, if you're unaware in terms of how to differentiate a y term only with respect to x, I have created a video explaining the process, and I'll provide a link to that video in the description below. However, in this very example, to differentiate a y term only, which is hyperbolic sine y, with respect to x, we need to use the chain rule. So let's use the chain rule to differentiate y with respect to x. So the chain rule says we need to differentiate that y term only with respect to y. So we need to differentiate hyperbolic sine y, the y term only, with respect to y, and then we multiply by dy over dx. So that is the chain rule. Now, if I differentiate hyperbolic sine y with respect to y, we get hyperbolic cos y times dy over dx is hyperbolic cos y dy over dx. So that is the derivative for when you differentiate hyperbolic sine y with respect to x. So let's include that in the main calculation. So for the left, we have hyperbolic cos y dy over dx, that is equal to, on the right hand side, as we discussed, root x is the same as x to the power half, and if we differentiate x to the half, we'll get half x to the minus half. So multiply by the power and subtract 1 from the power. That can simplify to 1 over 2, so let me leave the 2 as is. X to the minus half, that's the same as 1 over root x. So let me therefore rearrange for dy over dx. So dy over dx then will be 1 divided by the 2 root x into hyperbolic cos y, if I divide both sides by hyperbolic cos y. Now, we can write this answer for dy over dx in terms of x. So in order to write it in terms of x, if it's possible to rewrite hyperbolic cos y as a hyperbolic sine y term, then we can replace all of the hyperbolic sine y terms by x. Now it is possible to replace the hyperbolic cos y, okay, and rewrite that as a hyperbolic sine y term. So we can rewrite the hyperbolic cos y as hyperbolic sine y using an identity. So the identity in mind is this one. So I'm going to be using the fact that hyperbolic cos squared y minus hyperbolic sine squared y is equal to 1. So this is the result of the trigonometric Pythagorean identity as well as Osbourn's rule. So if you're unaware of Osbourn's rule, I'll provide a link to a video that I've created explaining Osbourn's rule in the description below. Now if I rearrange this identity for hyperbolic cos y, then hyperbolic cos y will be the square root, so it's the square root of 1 plus hyperbolic sine squared y. So if I replace the hyperbolic cos y term then by this term, we're going to have that dy over dx, that is 1 over, so 1 divided by 2 root x, and hyperbolic cos y is the root of 1 plus hyperbolic sine squared. Now we're nearly there, because since hyperbolic sine y we can replace by root x, I can then therefore rewrite this hyperbolic sine squared y term as x. Okay, so since hyperbolic sine y is root x, let's rewrite this answer as dy over dx, that is 1, and it's 1 over, so it's 1 over the 2 root x into the root of 1 plus, so 1 plus, if hyperbolic sine y is x, that makes hyperbolic sine squared y x. So that should be the solution to the first part. So let's go back to the question. So for part B, hence or otherwise, find the integral between limits 1/4 and 4 of 1 over the root x into x plus 1 with respect to x, giving the answer in the form ln a plus b root 5 over 2, where a and b are integers. So let's have a look at how that is done. So back to the paper and pen. Here's question 4 part B. We need to solve this integral. Now from part A is going to help us. We know that dy over dx is 1 over 2 root x into the root of 1 plus x. Now we could rewrite this as, so let me continue over here. We can rewrite dy over dx as 1 divided by, now I can combine these two roots, so we'll have 2 outside. Let's combine these two roots together. So we're going to have 2 into the root of x into 1 plus x. Now bearing in mind that integration and differentiation are reverses of each other, we can use this fact in order to help us with this integral. So in this case, if we integrate, so think about this, according to this result, if we integrate 1 over the root of x into 1 plus x with respect to x, we must get 2 inverse hyperbolic sine root x. Because if we differentiate hyperbolic sine inverse root x, so if you differentiate hyperbolic sine inverse root x, we got 1 over 2 root of x into 1 plus x. So that means that if you integrate 1 over x into 1 plus x, you're going to get twice of hyperbolic sine inverse root x. So that is the trick with this question. So in this case, we can rewrite, the integral, and let me call this integral number 1. So we can rewrite the integral number 1 as, so since this is the answer of the integral, let's include square brackets, and let's include the answer 2 inverse hyperbolic sine of root x, and the limits in this case are 4 1/4. Now it's very straightforward from here on. Let's replace the limits. So upper limit goes in first. Upper limit is 4, so I'll have 2 inverse hyperbolic sine of root x replaced by 4 minus, and if I replace the lower limit being 1/4, I'll have 2 inverse hyperbolic sine of root x replaced by 1/4. So if we go one stage further and simplify these roots, we're going to end up with 2 inverse hyperbolic sine root of 4 is 2 minus 2 inverse hyperbolic sine root of 1/4 is half. Now there is a result for the definition of the inverse hyperbolic sine of x. We can use the definition for the inverse hyperbolic sine of x to simplify these two terms. So remember the definition. So we can use the fact that the definition of the inverse hyperbolic sine of x is ln x plus the square root of x squared plus 1. So we can use this definition in order to rewrite our answer, in other words, in terms of ln. So let's apply this definition. Now, if you're unaware of this definition, I have created a video showing you the proof of this definition, and I'll provide the link to the video showing the proof and showing examples of how it's applied in the description below. So let's move on. Let me show you how this definition is applied in this case. So if I replace the x's in the definition by 2, we'll have 2. Replacing the x's by 2's will give us ln x replaced by 2 plus the root, and 2 squared plus 1 is 5. So that is what you will get as a result of applying the definition to the inverse hyperbolic sine of 2 multiplied by 2. Minus, let's do the same here. So we have 2 in front. If I replace the x's in the definitions by halves, we're going to have ln, so ln x replaced by half plus the root of x replaced by half, so we got a half squared, which is 1/4. 1/4 plus 1 is 5/4. So let's simplify this. So we'll have 2 ln 2 plus root 5 for the first term minus 2 ln, and if I simplify this term over here, we're going to have 1/2 plus root of 5/4 is the same as root 5/2. So now I can rewrite this as 2 ln 2 plus root 5 minus the 2 ln and half plus root 5/2. If I take out a common denominator, so let me take a common denominator of 2. By taking out a common denominator of 2, I'm going to have 1 plus root 5 on top. And what I'm going to do is, let me use the law of logarithms in order to rewrite this term. So remember, one of the law of logarithms that we can use the fact that ln A minus ln B is ln A over B. So let's use this law of logarithms to simplify this particular step here. So if I take a 2 common factor And if I use this law, I can rewrite this as ln 2 plus root 5. So just be careful when you apply the law. So divided by 1 plus root 5 over 2. So 1 plus root 5 over 2. So that is the law being applied. And I could rewrite this as 2 ln 2 plus root 5 divided by 1 plus root 5 over 2. That's the same as writing 2 into 2 plus root 5 all over 1 plus root 5. So that is what you should have as the argument. There's a lot of maths involved, as you can see. Now we can simplify this. Let me simplify this term as a side calculation. So we can rationalise the denominator to make this nice. So we have 2 into 2 plus root 5 over 1 plus root 5. So if I rationalise the denominator, if we multiply the numerator by 1 minus root 5 and the denominator by 1 minus root 5 as well, so if we rationalise, we're going to get, so let's multiply. So if we multiply the numerator, we're going to have 2 into, so let me leave this 2 as it is. 2 times the 1 is 2. So 2 times this 1 gives me the 2. 2 times minus root 5 is minus 2 root 5. Root 5 times 1 is root 5. And root 5 times minus root 5 is 5. So that is what you have when you expand these two brackets, leaving the 2 here, divided by, and when you expand these two brackets, 1 times the 1 is 1. 1 times minus root 5 is minus root 5. Root 5 times 1 is plus root 5. And root 5 times minus root 5 is minus 5. So this is the result for when you multiply the brackets in the denominator. So let's simplify. So we're going to have 2. So 2 from here. 2 minus 5, that is minus 3. So let's add the like terms. And minus 2 root 5 plus root 5 is minus root 5. So this is what you should have in the numerator so far. Divided by the minus root 5 and the plus root 5 we can cancel. 1 minus 5 is minus 4. Now from there on we can do a cancellation. 2 will cancel with 4, 2 goes into 4 twice. And if we also take a common factor of minus from the numerator, so if I take a minus common factor, leaving me with 3 plus root 5 over the minus 2 below. By taking out the minus common factor from the numerator, you can then cancel the 2 minuses, leaving us with 3 plus root 5 divided by 2. So that is what you should have when you simplify the argument here. Now let's use that. Let's use this simplified result. Let's rewrite this term over here in the main calculation. So back to the main calculation. We have 2 ln, so 2 ln. Now when we simplified the argument, as a result we have 3 plus root 5 divided by 2. So I can rewrite this as, so if I make this a power, I can rewrite this as ln 3 plus root 5 over 2 to the power of 2. So that can be achieved using one of the laws of logarithms, namely the power rule. And if you therefore multiply the numerator and the denominator, or if you square the numerator and square the denominator, you're going to have ln, so 3 plus root 5 squared, that will give you 6 root 5 plus 14 when you multiply, divided by, and 2 squared is 4. So if you apply the power 2 to both the numerator and the denominator, you should have this. Now, let's go one stage and simplify this. So it is possible to simplify. If I factorize the numerator, if we take a common factor of 2 from the numerator, we're ending up with 3 root 5 plus 7 on top, all divided by the 4 below. And then you can cancel the 2 with the 4. 2 goes into 4 twice to give you an overall answer of ln, and let me try and squeeze this in, 3 root 5 plus 7 all divided by 2. So that should be your final answer. ln 3 root 5 plus 7 all divided by 2. So that's a lot of mathematics for that particular part, so I hope you've understood that. And sadly, that ends this video. So I hope you enjoyed this video. I hope you found this video helpful. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice related problems, and I hope to see you again. Thank you.